Thanks for your interest. This is Dr. Swati Agarwal. In this video, I would be talking about various computational approaches used to tame unstructured data in big data. Data is like people. Interrogate it hard enough and it will tell you whatever you want to hear. Every organization understands the importance of data. However, data is useful only when it is interpreted into knowledge. But sometimes we just get too obsessed with it that our automated data processing models would end up answering like this. With actually so much of data around us, there is an urgent need of right technologies, methods, and computational power so as to uncover the hidden potential in these large-scale data, which is not possible with small-scale data. Now let us look at how much data is generated by Facebook alone on a daily basis. Worldwide, there are over 1.7 billion monthly active Facebook users, which is a 15% increase year over year. 1.13 billion people log on to Facebook as daily active users, which represents 17% increase year over year. On an average, the like and share buttons are viewed across almost 10 million websites daily. 5 new profiles are created every second. Photo uploads total 300 million per day. Every 60 seconds on Facebook, 51 lakhs comments are posted, 29 lakhs 80,000 statuses are updated, and 2 lakh 8,000 photos are uploaded. At first, this information may not mean anything to a lot of people. But with data like this, Facebook knows who our friends are, what we look like, where we are, what we are doing, our likes and dislikes, and so much more. Just imagine the possibilities of how such amount of data can be used to generate leads, direct you to your favorite neighborhood grocery store, or to compel you to make an online purchase of the latest cake your friend just bought. The economic impact is unprecedented. Let us do some quick maths here to find out the textual and image data that is generated in a day using Facebook. Assuming the average length of the comments and status to be, say, 250 characters and each character taking 1 byte, the total amount of data generated in a day is 214 GB. Assuming the average size of the photo be 2 MB, the amount of data generated because of the photo uploads is 613 terabytes. This just goes to show that on average day, Facebook alone generates about 800 terabytes of data, and this is a very conservative estimate, ignoring all other kinds of data generated such as creation of groups, pages, hashtags, geotagging, and numerous others. At this scale, conventional techniques to handle data cannot work. They simply cannot. Just to put things into perspective of how large amounts of data we are actually talking about, consider the following facts. As of August 2016, total worldwide population is 7.4 billion. The internet has 3.42 billion users in July 2016. There are 2.3 billion active social media users. 91% of retail brands use 2 or more social media channels. Internet users have an average of 5.54 social media accounts. Social media users have risen by 176 million in the last year. 1 million new active mobile social users are added every day. That comes out to be 12 new users each second. Facebook Messenger and WhatsApp handle 60 billion messages a day. 500 million tweets per day are sent worldwide. That is 6,000 tweets in a second. These numbers go on to show the tremendous pace at which the digital world is evolving. It is no wonder that conventional data handling techniques are failing to contain such massive amounts of data. This calls for great deliberation on how we plan to harness these data mines building up day by day. When we hear the term big data, the first thing that comes to our mind is that it must be data with huge volume, but that's not correct. Big data is a relative term and refers to a data which is impossible for an organization to handle. What is big data for one organization may not be a big data for the other one. An organization may not be able to handle the data because the data is voluminous, has a huge variety, or is accumulated with a great velocity. The general consensus these days is that some specific attributes can be used to define big data. In most big data circles, these are referred to as the 4 V's of the big data: volume, velocity, variety, and veracity. Volume is the amount of data we have. What earlier was easily computed in gigabytes has to be now measured in zettabytes or sometimes yottabytes. The IoT has led to an exponential growth in data. Velocity tells us the speed of incoming data that has to be analyzed and processed. To put things in perspective, the number of WhatsApp messages, Facebook likes, and status updates or credit card swipes that are sent every minute of the day give us just a hint of the velocity at which data is moving these days. Streaming applications like Amazon Streams by Amazon Web Services handle high velocity data. Veracity deals with the uncertainty in the data that is already present. The accuracy and trustworthiness of big data plays a big role when decisions are to be made based on it. To elaborate its importance, it has been estimated that poor data quality costs the US economy $3.1 trillion a year. Variety poses one of the biggest hurdles of the big data. It can be unstructured and it can include so many varying data types ranging from XML to videos to SMS to encoded text. Organizing the data in a meaningful way is no simple task, especially when the data itself changes rapidly. Data science is the science to obtain useful insights from the data and explaining those patterns. With ever increasing petabytes of structured and unstructured data, it becomes essential to extend the capabilities of conventional data mining methods to crunch, discover, learn, and secure hidden insights for the big data. The massive sample size of big data challenges the conventional computing infrastructures. Thus, the fundamental approach to store and process big data is to divide and conquer. For this, Hadoop is used. Hadoop automatically facilitates scalability and takes care of detecting and handling failures. Core Hadoop has two key parts: Hadoop distributed file system that stores and provides high throughput access to data stored across multiple machines. MapReduce, which is a distributed programming model developed by Google for parallel processing of large data sets. Let us consider a few examples to demonstrate how big data and analytics is changing our world right now. Big data is no more a technology of the future. Consider how banks can use big data and analytics techniques to generate profits. Fortunately, banks are taking advantage of big data, can generate revenues in whole new ways as big data provides more insights. Banks can analyze higher volume and variety of data from a whole many sources ranging from online spending pattern to mobile transactions, ATM withdrawals and whatnot. Banks, by analyzing data generated from each user, can suggest customized products which the user is more likely to invest or buy depending on his or her spending patterns. Say, for example, if a person spends more online in comparison to retail outlets, he or she is more likely to be interested in a credit card that offers higher benefits for online purchases. Let us consider how big data can provide a deeper insight into customers' buying habit in a retail outlet. In comparison to the online realm, collecting data can be trickier in the actual physical world. For this purpose, retail outlets may use your cell phone to track your entry or exits. CCTVs may be employed to take your image and track your movements and time spent in each section in the store. If you make a purchase, your mobile number can be used to keep a track of your purchase history and so on. By making proper use of all this data, the retail outlets may be able to provide their customers an enhanced customer service and relationship management. Find new source of profits by suggesting items that are of potential interests. Better competitive power by notifying customers of deals and discounts based on purchase history. Improved advertising. Targeted advertising campaigns may be created to make sure old customers return depending on the demography where bulk of customers live. Tapping new potential customer and highlighting the strengths of the store based on purchase history. Thus, we see how big data and analytics can provide new revenue streams not only for online business but also for offline stores. Broadly, data science process can be classified into three categories. Data pre-processing is the process of manipulating data prior to actual mining steps. It aims at improving the quality or the performance of data mining algorithms. Data pre-processing can be divided into several categories: data cleaning, integration, transformation, reduction, and compression. Data processing refers to the science of making sense out of raw data. This step transforms raw data to yield useful information. It involves data storage, organization, modification, and final presentation of the desired information. Processed data comes in the form of reports, diagram tables, audio, video, graphic, text, and other forms. Data analytics, the process of evaluating data using analytical and logical reasoning to examine each component of the data provided. Data from various sources is gathered, reviewed, and then analyzed to form some sort of finding or conclusion. There are a variety of specific data analysis methods, some of which include data mining, text analytics, business intelligence, and data visualizations. Data for any application domain is being generated by multiple sources, like via sensors, log entries, various task specific records, and many more. These may represent structured as well as unstructured data. So, there arises a need to convert information rich, unstructured data into a data representation that exhibits a higher grade of uniformity before it can be used for any kind of analysis. Also, even for a structured data gaps, indeterminacy or redundancy may be observed in the data captured. So, it is imperative that suitable data processing techniques be applied to the data acquired from multiple sources so as to get a more coherent view of the data. Data pre-processing forms an important step of big data analytics, which constitutes of about 70% of the total time. It is well known that prediction accuracy is compromised while dealing with scarce and precise data. While macro level data provides with the leverage to have 360-degree view of the data. The fundamental supremacy of big data lies in handling macro level data that provides decision makers with the significant insights and revealing implicit correlations in the data. The added data points augments the problem of chaotic data, that is unstructured in nature. Chaotic data refers to inconsistent, indeterminate, and uncertain data. Big data models often have to deal with such data. It is very likely that the data available to big data models is originating from multiple sources, thus leading to inconsistent formats. Imperfection of the data could also arise from the limitations of the devices that are used to measure, record, and examine information. Also, big data models often come across situations where it is to deal with the indeterminate data due to lack of availability or have to rely on uncertain data where ambiguity is inherited. This webinar would highlight upon this issue of unstructured data, an important aspect for big data models. It would be discussed in the webinar how various computational intelligence techniques can be employed in dealing unstructured data, thus improving the quality of the data supplied to various big data approaches and algorithms. The computational intelligence techniques would be discussed to handle different attributes of the data like inconsistency, indeterminacy, and uncertainty. It is quite comprehensible that a processed quality data input would for sure have cascading effect on the results generated. With high dimensional datasets, dimensionality reduction techniques are becoming very important. Extracting relevant features from a pool of sourced set of features is an extremely important step in data pre-processing, thus eliminating redundancy and noise. This removal of unimportant attributes helps to reduce load on data analytics techniques. These are the commonly used machine learning based feature selection methods. Several works reported in for feature selection that uses various computational intelligence techniques for big data are listed here. Conventional techniques do not scale well for big data, so various modified methods have been suggested by various researchers. Feature weighing is a process of assigning higher weights to relevant features and close to zero weights to irrelevant features, thus improving classification accuracy and discarding irrelevant features. These are the commonly used machine learning based feature weighing methods. To handle scalability issues in big data, various modified feature weighing techniques have been developed. Discretization is one of the most important tasks in data mining process, which is aimed at simplifying and reducing continuous valued data in large data sets. Discretization causes improvements in learning, speed, and accuracy. These are the commonly used machine learning based discretization methods. Conventional discretization techniques do not work well for large scale. Some modified discretization techniques have been reported for big data that scale well for huge data. Prototype reduction techniques are basically instance reduction techniques that work towards improving classification properties of nearest neighbor rule. These techniques may select instances from the original datasets or build new artificial prototypes to form a resulting set of the prototypes that better adjust the decision boundaries between classes in nearest neighborhood classification. These are the commonly used machine learning based prototype generation methods. Several works have been reported for computationally intelligent instance reduction methods using map reduced based framework for big data problems. There are often examples of real world applications in which there are negligible number of instances associated with a class, and it is usually these classes which are under study. So the correct classification becomes even more important. There are various data sampling techniques that handles this problem by pre-processing imbalanced data. Data sampling techniques can be categorized into three groups or families. Undersampling methods, which create a subset of the original dataset by eliminating instances which are usually majority class instances. Oversampling methods, which create a superset of the original dataset by replicating some instances or creating new instances from existing ones. Hybrid methods, which combines both sampling approaches from above. To obtain fast, scalable and parallel implementations, several data sampling methods have been reported with MapReduce that divides the original set into subsets which are more easily addressed and then combines the partial solutions that are obtained. Big data brings innovative prospects to modern society and tests to data scientists. These challenges are characterized and demand for novel computational and statistical paradigm. This webinar gives an overview of the various challenges imposed by big data with a focus on various researched data pre-processing techniques. Data preparation is a significant step as it directly impacts the efficiency and accuracy of various analytics programs. It is believed that this webinar would help the viewers in understanding how various computationally intelligent techniques can be employed in pre-processing the noisy, heterogeneous, and a higher order dimensional big data. Finally, I would like to acknowledge my students who were working with me in making of this webinar.